Okay, so in the first half of this class, we saw cosine of a minus b and a formula for, while we can't distribute the cosine function, we do have a relationship that does somehow split up the a and the b that are inside the parentheses. So it turns out there's 4 of these sum and difference identities. We've talked about cosine of a minus b, and I want to talk about the formula for cosine of a plus b. And I want to talk about this formula because I think it's kind of cool how we get this formula. So we're going to talk about how to derive the formula for cosine of a plus b. Okay? And we're going to do that from our formula for cosine of a minus b. So the very first thing I want to do is remind myself about that formula for cosine of a minus b. Now, I just introduced that to you in the last part of our lecture, and so that was like a first date. You don't know everything about that formula yet, but you do know its name, and you can look up all the information about it. And so we know, and maybe I'll write that here, we know that cosine of a minus b is equal to cosine of a times cosine of b plus sine of a times sine of b. Okay? And what we want to do is that we want to come up with a formula for cosine of a plus b. Now, I could just tell you what that formula is, but that's not so much fun. And I think this is really cool. So I do want to show you this. All right, so cosine of a plus b, what we're going to do is we are going to manipulate this expression here. Now, what I know is I know a formula for when I subtract stuff. When I subtract a minus b, I don't have a formula for the addition, and that's what we want to come up with. So check out this clever move. I did not come up with this move, but it is clever. Instead of writing a plus b, I'm going to write a minus negative b. And you should convince yourself that a minus negative b is exactly the same as a plus b. If you have minus and negative, that turns into a plus. Okay, so having done that clever thing, here's what's going to happen. The role of a in our formula that we know is going to be played by a down below. But everywhere that I see a b up in the original formula, I'm going to replace that with a negative b, because the role of b in the original formula is now being played by negative b. So let's write some stuff down. Cosine of a minus b is cosine of a, so that's what we have, cosine of a, times cosine of the second angle, which for us is negative b. So we have cosine of a times cosine of negative b, plus sine of a, so sine of our first angle, times sine of our second angle, which is negative b. Okay. All right, now this new expression that I have here, what you might notice is we have some negatives attached to our angles, and we have a couple of identities that talk about what to do with negatives. We have those even and odd identities. So the even and odd identity for cosine, well, cosine is our even function, and so the even identity for cosine says that cosine of negative x is equal to cosine of x. And for the sine function, our odd identity is that sine of negative x is equal to negative the sine of x. Okay, so we're going to write some new stuff down here. We still have cosine of a. Cosine of negative b is the same thing as just ignoring the negative sign. So we have just cosine of b, and then a plus sign, sine of a. And now when we have sine of a negative angle, the way we can deal with this negative for the sine function is to bring it out in front. So we have sine of a times negative sine of b. All right, so cosine of a times cosine of b plus sine of a times negative sine of b. To clean this up, I'm going to take this negative sign and put it here in the front of sine of a times sine of b. And so then I'll have plus a negative. So my final way to write this is I can write cosine of a times cosine of b minus, hi Franklin, are you here to help us? Minus sine of a times sine of b. And so what we've just written down is that cosine of a plus b is equal to cosine of a times the cosine of b minus sine of a times sine of b. And what you might notice is that the only thing that changed was up here we had our minus sign inside the parentheses, and that was opposite of this plus sign over here on the right side of the formula. On the other hand, we have a plus sign down here and the opposite over on the right side of the formula, which is a minus sign. Okay, so now we have two formulas, and there are two more. Now, we're not going to go through the details of the other two, but I do want to write them down so that you have them. You want to kind of keep these. We have our fundamental identity toolbox, and then we have this sort of secondary collection of identities that you'll sometimes use, but they're kind of in a specialty box. All right, well, we are back. So I want to list all four of the sum and difference identities. We've talked about two of them, the cosine difference identity, the cosine sum identity, and then we have the same similar ones for the sine. And so here they are, all four, the sum and difference identities for sine and cosine. Okay, so the first two that I'll list are the ones that we've seen. Cosine of a minus b is cosine of a times cosine of b plus sine of a times sine of b. And then we have cosine of a plus b, which is cosine of a times cosine of b minus sine of a times sine of b. And again, I do want to emphasize that it's not okay to distribute that cosine function through the parentheses. If you want to get the a and the b apart from each other, these are the expressions that you need to use. Okay, so we have similar ones for the sine function. So we have sine of a plus b is equal to sine of a times cosine of b plus cosine of a times sine of b. And our last one is sine of a minus b is equal to sine of a times cosine of b minus cosine of a times sine of b. So while you don't need to memorize these, it's a good idea to be familiar with them and know that if you do want to split up an a and a b, you need to use one of these formulas. All right, so we have our four sum and difference identities that we've written down. We have not talked about how to get any of them except for cosine of a plus b. But you want to be comfortable with these guys. And you also want to be able to use them. So our final example here is going to be another example where we are going to use these, at least one of the sum and difference identities. So in this example, we are asked to find the sine of 5 pi over 12. And we are not supposed to use a calculator on this problem, which means we do not want to have any decimal approximations. All right, so looking at this angle in here, I already noticed that 5 pi over 12 is not one of my normal angles that's normally part of the unit circle or any one of the special angles that we have been looking at this semester. So I'd like to know what 5 pi over 12 is so I can have a picture in my mind. Now, there's no degree mark here, which means that this is a measurement in radians. And so I'm going to convert this to degrees. So we have pi radians on the bottom and 180 degrees on the top. And I can cancel some things. The pi and the radians cancel. And I could just multiply straight across the top and straight across the bottom, but then I have large numbers to deal with, and I'm doing this by hand, so I'm going to try and do some canceling ahead of time. Right off the bat, I don't know how many times 12 goes into 180, but I know that 6 goes into both of these numbers. So 6 goes into 12 2 times, and 6 goes into 180, 6 goes into 18 3 times, so 6 goes into 180 30 times. And now I look at this again, and now I know that 2 goes into 30 15 times. So what I'm left with is 5 times 15 across the top. And so 5 times 5 is 25. And I end up with 75 on the top and 1 on the bottom. So this tells me that 5 pi over 12 radians is equal to 75 degrees. Now, 75 degrees is definitely not one of our special angles. Our special angles are 30 degrees, 45 degrees, and 60 degrees. And so I might ask myself, is there any way that I can add or subtract any of these angles to give me 75 degrees? And the answer to that is definitely yes. I know that I can write 75 degrees as 30 degrees plus 45 degrees. Okay. Now, there are also other ways that I can get 75 degrees. In fact, any of the angles on our typical unit circle with the special angles drawn in may be able to be used to combine to get 75 degrees. So, for example, if I have my high-tech unit circle over here taped to the wall, let's see, if I want 75 degrees, I can take 120 degrees minus 45, because 120 minus 45, 11 minus 4 is 75. So another way to get 75 degrees is 120 degrees minus 45 degrees. A third way that I could get 75 degrees is I could take 135 degrees minus 60. So 135 degrees minus 60 gives me 75 as well. Okay, so I've come up with 3 ways to add or subtract special angles, any of the angles on the unit circle, that will create 75 degrees. So I'm allowed to choose for my A and my B. I can either choose 30 and 45, 120 and 45, or 135 and 60. It doesn't matter which set you choose. I'm going to go with the first set just because those angles are in the first quadrant. But I would encourage you to try using one of our sum or difference formulas with 120 minus 45 or 135 minus 60 and see if it works out for you. You should get the same final answer that we get by using 30 plus 45. Okay, so we are going to use 30 and 45, which means that we will be using the sign of A plus B, because over here we have two angles that are being added together. So I'm going to write that formula down here at the top before I erase the rest of it. Sine of A plus B is equal to sine of A times cosine of B plus cosine of A times sine of B. Okay, now our goal is to calculate the sine of 5 pi over 12, which we figured out that 5 pi over 12 is the same as 75 degrees. And we're going to write 75 degrees as 30 degrees plus 45 degrees. Okay, so now I have the sine of two angles being added together. The 30 degrees is playing the role of A in the formula. The 45 degrees is playing the role of B. So what we have is sine of A plus B is sine of A, so that's sine of 30 degrees, times cosine of B, so that's cosine of 45 degrees, plus cosine of A, so that's cosine of 30 degrees, times sine of B, so that's times sine of 45 degrees. If I have each of these values memorized, I can just write them down. If I don't, I might refer to a unit circle with the ordered pairs on there, or I can draw my 30-60 right triangles. However I choose to figure out or write down the sine of 30 degrees, the cosine of 40 degrees is totally fine. So I like to draw the triangles. So for the 30-60 triangle, we have sides 1, 2, and square root of 3. And for the 45-45 right triangle, I have sides of 1, 1, and square root of 2. So when I write down the sine of 30 degrees, sine is opposite over hypotenuse, so the sine of 30 degrees is 1/2. Cosine of 45, adjacent over hypotenuse, that's 1 over root 2. Rationalized is root 2 over 2. Then I have a plus sign. Cosine of 30 degrees, adjacent over hypotenuse, is root 3 over 2. And sine of 45, opposite over hypotenuse, 1 over square root of 2. Rationalized is root 2 over 2. Okay, so we found all the trig values that we need, and now we want to clean up these numbers. So 1/2 times root 2 over 2, I can multiply across the top and I get root 2, multiply across the bottom and I have a 4. Then I've got the plus sign. Multiply root 3 times root 2, I have root 6. On the bottom, 2 times 2 is 4. Final step, I want to combine these fractions. They already have a common denominator, so I end up with root 2 plus root 6 divided by 4. And so we've just calculated that cosine of 5 pi over 12 is equal to root 2 plus root 6 all over 4. That looks like the same number that we came up with on the on the last example, the one we did early on in the class today. It is the same number. They won't always be the same number, but in this case they are. Now I would encourage you to take a look at one of these other two combinations. So maybe take a look at maybe 135 degrees minus 60. If you're going to use 135 degrees minus 60, you're going to be using the formula for sine of A minus B. And when you calculate things like the sine and the cosine values, you'll need to think about sine and cosine of 135 degrees. So that is an angle over here in quadrant 2. Okay. So try that out and see if you get the same values. If you don't, send me an email. If you do, and you want to show me what you came up with, send me an email. All right, thanks for listening today, and remember to come back for the second part where we come up with the formula for the difference identity for cosine. All right, thanks.